Okay, before you begin the video, hopefully you have answered the 3 questions after you study the key concept. If you haven't, then go to Lesson 3.2 in your textbook on Solve Multi-Step Equations and study this key concept box, and then I have 3 questions for you. Either that or you can pause the video, but you'll have to go back to my big campus to find your 3 questions. We're going to be modeling equations with algebra tiles just like we did last time, using zero pairs and grouping them into equal groups. It's important that you understand the order of operations. Remember PEMDAS, parentheses, exponents, then do multiplication, division left to right, and addition, subtraction left to right. And we're also going to use inverse operations to undo operations in equations. So go back and answer those 3 questions. You'll find the answers in the next box on your home page of your bundle, and then you can go on. Okay, for example 1, we're going to solve 2x minus 5 is equal to 3 using the algebra tiles. So notice we have 2x's and negative 5, and we've got it equal to a positive 3. Well, since we have negative 5's, we're going to have to add positive 5 to this side. Same thing to this side, because whatever we do to one side, we do to the other. That means that all of these will zero out. So we're going to have 2x's and 5 plus 3 will 8. We'll have them in 2 different groupings. So each x is equal to 4. Okay, with that in mind, let's go back and we'll work this equation. It's now your turn to solve 3p plus 2 is equal to 8 using algebra tiles. Okay, notice they've modeled for us here. We've got 3 x's, which takes the place of 3p. It doesn't matter what the variable is. Plus we have 2. And then on the right side we have 8 ones. So to make zero pairs, we're going to have to add 2 negative tiles. Whatever we do to this side, we have to do the same thing to the other. That means those groupings are going to disappear. So we're left with 3 of the variable, and if we divide each of what's left over into equal groups of 3, they each have 2. So x is equal to 2. Well done. Now let's look at example 2. This one's a little different on this side because we have a fraction. That's all right. The fraction is directly with the n, so we've got to take care of what's being added or subtracted first. So we're going to use the inverse operation of subtraction, which means we're going to add 2.5 to each side. That's going to leave us with 1/10 n is equal to 10. Well, then we're going to divide both sides by 1/10, which is the same thing as multiplying by the reciprocal. In this case, 10 over 1. So n is equal to 100. We go back and we check our solution, substituting in the 100 for n in our original equation. We do get that 7.5 is equal to 7.5. Okay, now it's your turn, so pause the video and you can work this problem. Alright, did you get that you needed to subtract 50 first because this is a positive 50, so the inverse operation is subtracting 50. We end up with negative 3b is equal to negative 15. So we divide by whatever's with the variable. We're going to divide both sides by negative 3. Negative 15 divided by negative 3 is a positive 5. We go back in and we check our solution. 50 minus 15 is 35. Good job. Time for a little guided practice. We're going to solve each of these equations, 1 and 2, using algebra tiles. So we're going to have 3 x's and 7 negative 1's, and on this side we're only going to have 1 negative 1. Here we're going to have 2 of the x's and 5 positive 1's, and on this side a negative 3. So do your zero pairs and see what you come up with. Also, in the meantime, some step-by-step practice. Try this and we'll come back and I'll give you the solutions. Okay, did you end up with b is equal to 2? Good job. And on this one, m is equal to negative 4. Very good. So just like we have learned doing proofs in geometry, we start with what's given. We're going to start with adding and subtracting, so this is an addition, positive 3, so we're going to subtract 3 from both sides. We're left with 1.5r is equal to 6. We divide by whatever's with the variable, so we're going to divide both sides by 1.5. So r is equal to 4. We're going to test to see if we worked our equation correctly, and we do end up with 9 is equal to 9, so it checks. Good job. Now it's time for us to work an equation without algebra tiles. So I want you to pause the video here in a little bit, read through the problem. This even tells you your reasons. On this one you'll have to list your reasons yourself, then come back in a little bit and we'll go over the problems together. So we have 9 being added to this variable, so we're going to subtract 9 from both sides. Then we have to divide both sides by 6 because we're left with 6y is equal to a negative 24. So y is equal to negative 4, and it does check. On this one, we're not going to worry about the fraction for a little bit because we've got to add 5.5 to both sides. Then we're going to multiply by the reciprocal of 2/3, which is 3 over 2. And whatever we do to one side, we do to the other. So x is equal to 27, and that's done because we're simplifying. Substitute a 27 in for x in your original equation, and it does check. Good job. One more thing to work on before we go on to our individual practice. Okay, time for problem solving. So I want you to pause the video, read through the problem, make a note of any keywords that you notice. How are you going to make a plan for solving this problem? And then show me what your answer is, and don't forget to check. That's a good way to find out if you've gotten the right answer or not. Our keywords are our equation. We're wanting to know the number of hours that is represented by h. So there's our equation, knowing that h represents the number of hours. This one's sort of backwards from what we're used to working. So we're going to subtract 19 from both sides, and then we're going to divide both sides by 7. So the number of hours he worked was 9 is what we found out. We're going to use inverse operations to solve this. Then we're going to substitute back in. If we put 9 in place of h, do we get 82? I believe we do. So it's time for you to do your individual practice, and then it'll be time for a progress check.